So, hello. What'll be good to do at the first is to just give a brief introduction of what I do, and then get to know you guys a little bit, so I can tailor this course to hopefully fit what your needs are. So, yes, I'm Jay. I've been a data scientist for about 12, 13 years. I started actually at dunnhumby many years ago, and then from there worked in various places. It's probably interesting to talk about my latest client, actually. Did you see the news yesterday about the doctor who had all those operations which were unnecessary? I'm actually working for that insurance company now, and my brief is to bring data science into that company, because they're traditionally they use SAS, which is quite a old-fashioned, I would say, not data analytical tool. It's not necessarily a data science tool. So they asked me, all right, Jay, could you come in and could you introduce data science into our organization? So I went there. I spent 2 weeks understanding the business, literally talking to everybody on the board, people in all the different departments. And the commonality between everybody was the biggest thing we need to do is find those rogue doctors, because those rogue doctors are the ones who account for something like 95% of all the claims. Because you can have a claim which costs tens of millions of pounds, basically. And if you can spot that before the event happens, then that's going to obviously lower premiums. So I'm going to actually might interject this into what I'm doing here, but I'm going to kind of talk about the approaches you can do to try to solve this problem, because that actually it's a really big problem. It's very difficult, but there's certain techniques you can use. So what we're going to do today is basically a workshop. So I've had my ideas about what I think you can do to create a data science project, but one of the key things about data science is it's collaborative. Now, I have experience, I have ideas, but if you get a group of people, it doesn't matter if you have lots or no data science experience. That one person who has no data science experience, he can come up with one idea which could change everything. You can come up with one idea that says, actually, have you looked at this data? Have you looked at these factors? And that could be the key to open up to solving the problem. So please, I would love you guys to contribute as we go on. So that's me. Back to you guys. So from what I understand, we have basically, say, 3 categories of people. So if you're a student of data science or data analytics, could you put your hand up? Okay, cool. If you're a current data scientist now working, could you put your hand up? Cool. And those who want to transition into data science, put your hand up. Okay, cool. And who's just generally interested, maybe have their own company and just kind of want to see what we can do? Okay, cool, that makes sense. Okay, so this hopefully will be relevant to all you guys. So let's get started then. Any questions at the start? Just chip in, it should be quite casual, so. No? Okay, cool. Right. So the question is, what factors are the most important to predicting a success of a data science project? Let's say this is in the context of a company who hasn't had a data science organization, kind of a capacity before. So let's shout some out. So I've actually created this list already, but I might have missed something. Or so yeah, what do you think? So if you were going to create a data science department in your company, what do you think will dictate, or what do you think are the main features, whether that department in your new data science department in that organization is going to produce actionable insights, which is going to change the business for the better? And there's a big distinction here, because you can have a data science company. Actually, I have a client. We've recently worked with a client, and it's massive. It's a huge insurance client. And We went in there and we said, oh, okay, so what do you currently do? And so they talked about all these types of prediction of algorithms and scoring systems, et cetera, et cetera. And we said, okay, so how successful is it? Does it work? And what the head of data science said was, we don't know. It's more common than you think. And he said, oh, well, how do you not know if your work is successful or not? And he says, well, we create these, say, for every user, we create a prediction score, whether they're going to lapse or not, or whether they're going to respond to an email campaign, which is quite common. And we just give it to the marketing department. And we don't know if it works or not. We don't know. We don't get any feedback. And that is more classic than you think. And that is not a successful data science company. And hopefully we can try to change that culture. And there's a lot to do about culture as well. So, okay, so what do you think?
I'm going to suggest that the language that we formulate the problem in is going to be one of the predictive factors.
Okay, sure. That's a very good point. Okay. The usability easily understood. So if we're not using the same common language, and we don't really understand what we're all on about, how can we collaborate? It's actually kind of key. That's a great point. Thanks. Anybody else? Yeah?
The right kind of data.
Yeah, great. Okay, what do you mean by right type of data?
Quantity, quality, relevance.
Okay. Incredibly important. Yep.
Well, moving on from that, it's the right data infrastructure. So in a lot of companies, there is good quantities of data there, but it's different places, and it all needs to be brought together in order to be accessed properly.
No, that's incredibly important. I was working for an organization, a very big one, and they had all their data in about 300 databases. And they try to do a project where just want to say, okay, let's put all the data in. Like they talk about single source. Let's put all the data in one place so we have a single customer view. Okay, it never worked, obviously, because it was just too complicated. And in that case, the problem was the goal was to create a single customer view. But that should never be the goal of a data science project. The data science project's goal should be, can we produce analysis which is going to change the business? And it's actually a fine distinction, but it's actually a really important distinction. Anybody else? Any?
Right people.
Okay, cool. So what do you mean by right people?
Appropriate skill sets, education, abilities,
Cool.
knowledge.
Yeah, that's great. And anybody else? Yeah. Go on.
Portion of time spent understanding the question and your decisions rather than spending time spent coding.
That's a great point. So portion of time spent understanding problem versus, let's say, coding. Cool, that's great. Anybody else? Sorry?
The financial benefit to the company.
Yeah, sure. What do you mean by that?
Quantify the various predictions around them.
Yeah, that's great.
To reality.
Prioritize. I say prioritize use cases. Okay. Cool.
Whether or not the incentives of the data scientist team are aligned with that of the business.
Oh, that's a great point. Yeah, incentives aligned. Have you seen my slide before? Presentation before? Okay, cool. Yeah.
Also setting objectives and framing the overall, what is success as far as metrics, objectives.
Yeah, that's great. Yeah, so framing or setting overall strategy and KPIs, I'd say.
Being willing to change.
Yeah, great point. Yeah, culture of change. So one of my best friends is like head of one of the biggest mobile providers. He's just about to leave, actually, because of this, because of culture of change. He says, he goes into, so he's like head of analytics. He says, he goes into the boardrooms, and he talks a lot. And they go, yeah, great. But they never do anything. They never actually do anything because they're happy as it is. His conclusion actually is, in that company, and his last one, which is one of the biggest airlines in the world, was if you took actually out the data science team or data analytics team, nothing would change because there's no link between their work and actually the profitability of the company. So in fact, he is worse than zero, basically, because his department is, say, 100 people big, but it's not actually producing anything beneficial. And that's really common, actually. Okay, cool. Anything others? Team structure.
Data science are in the product teams and not just on their own.
Okay, not. That's a great point. It's all about collaboration, I'd say. Yes?
I'm going to say integrity, Jay.
Oh, wow, that's great.
Not only referential integrity, but the integrity of different aspects of the project.
That's actually really important. Yeah, we'll go back to that. Yeah.
Right scope.
Right.
Not too big, not too small. And a client in a broad sense. So someone should really want it.
Yeah, that's true. That is very true, actually. So what often happens is you get somebody in a department, say maybe it's like head of marketing, and they go, oh, I've heard about this data science thing. It seems quite cool. And I probably did mathematics or something, or economics with a bit of stats at university. I'm really interested. So they've got a bit of budget, and they go in and they bring a data scientist like me, or they kind of trying to bring in one. This actually very often happens. I was chatting to one of the biggest law firms in the world. One of the biggest revolutions at the moment is bringing artificial intelligence into the legal field. So the legal field is incredibly backward, really, really backward. They barely use Excel, to be honest. But what's happening is that you've got these new law firms coming into the market, like Rocket Law, I think, is one of them. And they come in, and they're just very slick. They use data properly. They use kind of agile methodology. And they're just a better service. And then they're a lot cheaper. So what these big law firms are going, oh no, this is a big problem. So how can we counter this? Oh, well, we've heard about this data science, artificial intelligence. And actually, they've got a lot of data. So the kind of biggest thing at the moment is kind of the popular thing to talk about is artificial intelligence and natural language processing, where you've got a big body of text. So it's like Google, they do this a lot. So they have a web page and they kind of work out what it means and how it's connected to lots of things. So how can you get basically some notes on a case or a letter from a case or a court judgment which is relevant to that case, turn it into, so that's unstructured data, turn it into structured data and then apply it to a problem. And that's really, really difficult, really, really difficult. So what the biggest law firm did, one of the biggest law firms in the world did, they just got one data scientist because this one guy was interested. And so I talked to this data scientist and he was like, well, I can't do anything. One, because the IT went down. One because one because they don't actually have the data, they don't have the backup, they don't have the support. And actually the main problem was that the people in charge, the partners, they're not interested. Because when you're at the partner stage, at that high up level, you don't care. You've already made your money, and you're going to get out. So because the partners are not supportive of this one data scientist, I can guarantee it's not going to work, basically. So that's really key. Any of us?
Maybe the tools, what are
That's a really good point. Yeah, cool. Tools. Yeah. We'll talk about this, actually, later. But in summary, it's just one of the takeaways you should take out of this is, I would say this is very overrated as a predictor. Because what you have, I blame the marketing departments, basically, for a lot of these companies. Especially in marketing. I used to work for WPP, and like every week someone will come in and go, oh, we've created this new platform, and it's going to revolutionize everything. It has this unique algorithm, which is just incredibly intelligent. It never works, basically, because that's the end point. You need to have the infrastructure, you need to have the right data before anything's going to work. And because a lot of people say, oh, this tool's going to revolutionize everything, it's so intelligent. People think it's actually a lot simpler than it actually is. Data science is a slog. It's a marathon. If you think you can basically read in your data into a machine learning algorithm, and then after a few minutes it's going to magically come out with the answer, you're in the wrong place. Because if it was that easy, someone would have done it already. Basically, is one of the big things my teacher at Dunhumby said to me was, if it was easy, or if it was like, if the process was easy, or if the answer was really amazing, you're probably wrong. You've probably done something wrong. You need to QA it properly, and 99 times out of 100, he was right actually. So, anything else?
Focus of the data science department. So some companies might be really good at doing it externally, but they don't really bother internally, or the other way around.
That's actually a great point. I recently worked for one of the biggest consulting firms in the world, and they sell this. They say, oh, we can build you a new cloud-based infrastructure and incorporate all this new methodology. All this and all the latest techniques to other companies. That's their biggest selling point, right? Digital transformation. You hear this all the time, digital transformation. So I was brought in to basically transform their marketing department. And they had the smallest budget, they had the wrong people in there, and had loads of conflicts of interest. And again, I had to walk away, because I came in too late. I was at the inception, I wasn't there in the planning stage, and I was there to kind of fight a fire. And again, it never really works, because you need to have the foundations right. And hopefully this is what we're going to go through today. How can we build the right foundations? We'll take 2 more, then we'll start going.
Taking it from production, having skills.
That is really, really important as well. So the key to the future of machine learning is automation. And in the context of companies, how can we, let's put it this way. The people who do this at the moment, productionize AI, are Google, Facebook. Just say Google and Facebook first. So Google, every time you log into Google or YouTube, you have their automated, what should you look at? What video is interesting to you? That's AI. So that's called that's personalization of your feed. And the same with Facebook as well. So every single company should do that, because everybody's unique. So if you can, at Dunhumby, they talked about relevant marketing. If we could be instead of this mass market, buy Heinz baked beans, what you want to say is actually, Jay, hi, why don't you buy these baked beans on a Tuesday? Because I know, baked beans on Tuesday are your favorite, and actually this variety is really new. Stuff like that, you want to be able to talk in that language, and that's really, really important. Last one, and then we have to go. Yep.
Who's leading the data science team, whether it's a data scientist or somebody parachuted in from the business?
Well, I'm slightly biased in this, but that's actually really, really important. And the main reason is, so my friend who works for the mobile company, he is not a data scientist, and he's never done analysis. He's just been head of marketing, and he has absolutely no idea what he's doing, to be honest. And what happens is you get these people who know all the old techniques, and when you approach a problem, you just use what you know. and that's not going to be progressive. So who your leader is really important. So whoever you have, do they know the full scope? Do they understand what's possible, what's not possible? Do they understand what can work and what can't work? And then also, why would they care, basically? So, okay.
But I think it's the issue of leadership.
Leadership.
Because now we see that in science, there is multi-discipline science.
Yeah.
And data science would work with a lot with math, mathematicians.
Yeah.
With even a new technology in hardware, using quantum physics, nanotechnology, all this. But there is leadership who is open-minded and clever enough to widen his knowledge, so he is capable to address all of them.
Yeah, and that's really important in terms of leadership. How I would talk about leadership is can they inspire? Can they infuse? Can they explain? Because it's difficult. You know, if I tried to explain to you what a neural network would be, it's really difficult. So, and then can they collaborate, basically? And all these things, we'll talk about this very soon, equates to trust. If people trust you because you're open, you're collaborative, you work well together, and you share ideas, then that's actually one of the biggest, if not probably the biggest factor, I'd say, in dictating whether something's going to be successful or not. Okay, so very quickly, that's actually a fantastic list. And let's talk through it. So this is what I came up with. So data science qualities. One, I'll send this out to people, so you don't need to make notes. Number of algorithms you know, so, and how to use them. I think that's really key. I don't think there's any controversy there. Accuracy of experiment design and execution. What I mean by that is, do you know if your data is biased or not? Are you asking the right question? And do you have the right metrics to assess whether that question has been successfully answered or not? Let's put it this way. I recently was asked to come into a marketing agency because they had done a big survey. And it's a really important survey to do with Brexit, actually. So I said, okay, cool, come in. And they said, oh, can you just sign off on this? Could you just say, did it work or not? So I went in there and I went, no, because the way you've collected the data is wrong. So they did all this analysis on the back of basically flawed data because they hadn't constructed their experiment correctly. And it was basically, effectively, their project was useless. And they had spent 6 months on this project, 6 months. And it's a real shame because the intention was really good. And the reason why it failed was because the person who did it, he was a very smart guy. He got first, unrelated subject. And this often happens, actually. It kind of goes in. People go, oh yeah, I'll just do a course, or I know how to do a bit of Python or something. But because they don't necessarily understand what they're doing, and they've got this kind of arrogance. Arrogance is massive in data science because we have lots of smart people who care too much about how smart they are relative to other people. It's true. It's very true. We're all a little bit autistic. So basically, but he was blind. He was too arrogant. He didn't want to collaborate, and then he made too many mistakes because he wasn't willing to expose his work to other people before it was too late, and that's kind of key. What's really important, understanding the data, and that's kind of key. That's just a fundamental. Do you understand the data? Feature selection. So like this week, I was doing a hackathon in a company where they had 700 variables. And what's really important in data science is understanding if your output is for a machine or for humans. Is this for a machine? Are you just going to feed in a probability score to another machine, which is going to use that to automate something else, like a recommendation system or an email marketing system? It doesn't matter. But if you're presenting to a human, they need to understand what's going on. And actually, if you have loads of variables, it's going to be really difficult to explain. And they won't understand. If they don't understand what you're doing, they won't trust it. So therefore, the less variables, the better in terms of explanation. So sometimes it's best to have a slightly worse, prediction score, if you can explain what's going on a lot better, because at least you'll get buy-in. So that's feature selection. Ensembling, stacking experience, that's when you kind of combine lots of algorithms together to create an overall algorithm. So if you read any of the Kaggle blogs or Kaggle compositions, ensembling and stacking is probably one of the most, if not the biggest feature at that level, because they're all good. They should be all good data scientists, but it's how you ensemble and hence how you stack is really key. If you're a collaborator or a lone wolf, collaborations, sharing ideas is key. And it's because everybody makes mistakes. You have to kind of just accept this. Everybody makes mistakes. How quickly can you capture the mistake and fix it? It's all about iteration and quickness. So I think somebody mentioned this before. Internal standards of QA. What can happen is you can have a model and it kind of works, but you sort of have this intuition in your head, it's not great. At that moment, what do you do? Because and only you will probably understand what's going on. Only you will understand, will have the power to say, no, I'm not happy with this. And are you willing, as an individual, to say, no, this isn't quite right, I'm going to stop. I'm going to say to my bosses, sorry, it's not quite right, you need to give me another week or two, and then move on. That's integrity, to make sure that your work is really, really key. And I worked in one company in Australia where there was one guy who he had no standards, he had no integrity. And the way he hid it was in his code. You know, like code should be sequential like this. You know, so you start off here, this is a SAS code, and it kind of goes down. What he did, he wrote his code horizontally. So it'd go right down to there. Because he wanted to hide what he was doing. He wanted to hide how bad he was so he can keep his job. And it took me 2 weeks to work out what he was doing, and then he left the following week. Because his work was rubbish. And he was just trying to hide, because he had no integrity. Okay, so that's really key. Model speed development. How quickly can you create a model, basically? Because it's all about iteration. So when I recommend starting a new project, just create a model straight away. Have a baseline. So just have a score to beat. And that's really key, because it gains momentum, it kind of encourages you. Also, what's important is when you iterate, can you learn from what the model told you, the first model told you, and go, actually, yeah, that model's saying that these features are kind of good, or these features are worthless. Let's kind of get rid of these features and let's use this one. And can you iterate correctly? That's intuition, and that's based on understanding the data and understanding the problem. And also, in terms of presenting, can you create trust in your work, how you present it? So talk about kind of infographics and visualizations. That's actually really key. If you had the best analyst who creates the best results, and their models were perfect, and they can't communicate that to their bosses, it's not going to. That model is effectively useless. So, and this is kind of key to future data scientists. Can you present your work? And it's hard. I'm really nervous about this, by the way. I hate presenting, but I practiced. And you through practice you get better. So, okay, cool. Okay, so. The data scientists, these are factors. Usability of the data, I think this is kind of key to any data science problem. I think we talked about before. Data quality and data size. Obviously, the more data, the better, because a lot of these algorithms they have this presumption that historical incidents predict future incidents. Okay? So the more history you've got, the better. There are some techniques like Bayesian statistics which don't necessarily need that as much, but that's a little bit more advanced. Data accessibility and linking ability across databases, that's really key. So what you want from your data is the ability to understand the real life situation or context through the data sources, and the way you do that is by linking all the data together. So in a customer example, you have the like a web-based company, let's say dunnhumby, because I work there. They've got your transactional data for your club card. They have all your transactional. They have your website data, what you've clicked on inside their like Tesco online store. They also have if you clicked on any adverts which drove you, so your website data. They might also have through buying this data in, all the websites you've been on as well. And maybe they can have some other data as well. But essentially, if you've only got a little bit of your data, you can't actually understand potentially other features or other factors which affected your decision. And that often happens. A lot of the time you have companies who just say, right, we're just looking at our data, and what's important is what we know. But actually, a lot of people don't even care about what the competitors are doing. So if we have a marketing campaign and it just dives, from a response rate of like saying 10% to 5%, why? Why does it dive? And we go, well, nothing's wrong. But if you don't necessarily know that your competitor has got a half price promotion at the same time, then that's a really key part of information. So again, being able to link data together. Okay, so technology stack. So speed, flexibility, connectivity to data science tools. So in the old school, I unfortunately use SAS. And let's put it this way: I spent the last 3 weeks in a company trying to connect SAS to an SQL database. 3 weeks, 3 weeks, and that's madness. And I still haven't done it yet. They're actually SAS are going to charge me £800 to connect to an SQL database. That's what they quoted me. I'm trying to find a workaround, but that's mental. Modern tools like Dataiku, which are here, which I highly recommend you look at least. And this H2O.ai is very good as well for general linear modeling. It's really good because it's fast. You can produce. If I just had the data, I can produce like 100 models in one day, just straight away. And it connects to lots of things, and it's very flexible as well. So it has pre-built algorithms, but it also has, you can also write R and Python in it as well. If you have lots of data, you don't want to be waiting. Say, I wrote a program 10 years ago, took 3 days to run in SAS, just because it was too big, basically. Things like Spark, which is like parallel processing, it just speeds up the process. Again, because it's all about iteration. Create a model, learn from it, move on, and the more models you make, the better it's going to be. What's also important is number of legacy systems. If you have more legacy systems, it's going to take a lot longer to understand what's going on, because there's actually a lot of baked-in knowledge in there which you need to extrapolate. So I've only got 5 minutes left, so I'm going to be really quick. And also the ability to visualize, present, work effectively. Tableau is a very popular tool. Because, again, if you can present something in a nice way, it promotes trust. And also, I think one of you guys mentioned this before, how quickly can the analysis actually make a business change? In a perfect world, you have your analysis which creates like a automatic email score saying, okay, who should we, so the problem would be, who should we market this product to? It automatically goes through our system, it creates a score, takes the top 1,000 people who have the highest scores, and it automatically emails them instantly, because you've already set that up. The worst case scenario is, it took 3 weeks to create that algorithm, then you have to present it to marketing, who have to present it to the board, who then have to get it signed off, and then have to send it to creative, and then that has to be signed off, and that could take. So I used to work at Unilever, and their marketing cycle's a year. So you plan things a year in advance. The world is moves a lot quicker than that. So that's why I have APIs. So the tool should produce a score, which should be able to feed into like a system, which should then email it, which should then feed it back into the system to record it, show results, which should then feed back into the algorithm. It should be these loops, and that's kind of what the machine learning and artificial intelligence does. And this is kind of the thing which most people, you did actually talk about, which most people don't necessarily think about. So you could be the best analyst or data scientist in the world, but if there's not necessarily trust in the company about using data-driven decisions, you can't do much about it. So that's really key. These are massive, basically. A lot of employees are scared because they're scared for their jobs, and they're scared that there's all this talk about automation and they're going to take their jobs, because that's fair enough, to be honest. But these people will kill your project because it's in their interest, which leads us on to this one, which terms of conflicts of interest as well. So that's a shark who's a lifeguard. IT will try to kill you a lot of the time because they don't like cloud-based solutions. Because if you export your IT infrastructure to the AWS, then what's the point of them, basically? So they'll try to kill the system. I had one IT department who wouldn't install a program because it wasn't supported in Windows, basically. And then, so I couldn't install Dataiku in their systems. That's just mental, because that's what IT do. Is there an effective decision-making process? And do you actually understand what actually changes the business? I think this goes back to the original point. Do you not? And then, again, we've talked about this, the culture of innovation and iteration. That's also kind of key. And this is what I do a lot of the time. I go into a company and I create a strategic roadmap which incorporates data science, which basically says, your company has these threats, how are we going to solve these threats using data science, and then create these data science objectives which can be understood across the business. I've got 2 minutes left, so that's why I'm speeding up. And also, what's really key, what kills projects is, if it takes 2 years to prove something, you've lost the interest already. What you need to do is create momentum. So it says it's an easy win. Let's just create a lapsing model. Let's create a prediction model. Do that first. But get people to go, oh, that works, and then move on. And also, the kind of guru, correct level of expertise to guide and support the development. If you don't have that, it's just not going to work, basically, because you'll just make loads of mistakes. And you've got a chance. If you blow this chance, it's very hard to go back again, basically. So how do these factors relate to each other? So I've created this nice little diagram here. Right, let's talk about this very quickly. Aristotle said, paraphrase him a bit, success is a process, it's not an event. So you need to be able to do all these things as part of a process, part of a culture to be able to become a good data scientist. This is to do with solid foundation blocks in terms of your data, and that's to do with, have you got the right data model? Can you translate, basically, from the old system to the new system as well, integrate? And yeah, there's also lots of connections here. This is like a dynamic systems database. So how long have I got? Is that it?
Pretty much it.
Okay. Oh no. I'll send this around. But basically, you can see how there's connections and stuff like that. So what's really important, actually, is if you have one of these links which is missing, it doesn't matter what you do, it's going to break down. And that's really key. So sometimes you go, oh, it didn't work. But sometimes it's out of your control. And you just have to accept that sometimes. That's how the world is. OK, thanks very much. Yeah, maybe connect to me on LinkedIn, or I've got some business cards as well. So if you want to continue this conversation, or I'll be outside. OK, thank you. All right. Bye.
Okay, thank you very much to Jay Liu. And